a little deeper into some of the questions and comments raised during and after the last rental webinar that we hosted. So it's been really great to see the level of interest from companies and individuals across Europe and the rest of the world involved in the rental and staging industry. So we hope you're all well, and thanks again for joining, and we hope you like the webinar. So my name is Alex. I'll be supporting Christian during today's webinar, fielding questions in the background and making sure we stay on track as well. So before we start, just a bit of housekeeping. So we recommend that you open the webinar in Google Chrome for the best experience. You'll find the little icon by the window to dock your the speaker window, so you'll get the full view of the presentation. At the bottom right-hand corner, you'll see the chat box. So please feel free to use that to submit your questions. I'll be collating those in the background, going through them, and then in the second part of today's webinar, we'll pose those back to Christian as part of our Q&A session. In total, it will take about 45 minutes today. We're recording today's session, and I'll be making the recording available and also the slides after the show. So please do keep a lookout for the follow-up email. So with that in mind, I'll now pass you on to Christian.
Yeah, hello. Good morning to everyone. I really like to see some of you again after the first webinar, but I also welcome the new attendees within this webinar. And what is this webinar about? So I basically answer your questions. So I try to find or select the right questions or good questions out of the last webinar, in addition to the ones you sent us in advance. But I definitely will also reserve, similar than in last webinar, some time and hope enough time to answer your questions, which you will point out today in this webinar. So let us proceed with a selection of your questions. And here you have a short overview of the questions, which I'm now going to answer. What kind of LED product is needed for what kind of application? What are the main features and or advantages of LED technology? What is the right way to calculate the minimum and maximum viewing distance, which will also, by the way, include a little bit the point of view for viewing angle? What is the difference between batch and calibration? We got that question quite a lot of times. And last question is how to set up the ground support for a stacked LED screen. And I also pick up there some questions from last time, which ask what kind of ballast weight to be used. And as you see, I really try to find a good balance for your different range of questions depending on experience of LED. But keep in mind, come up with your questions already now during the webinar, which will be answered after those 5 questions. So let us start with the first one. So what product or especially what feature within the product is needed for what kind of application? Last webinar, we made the differentiation, or at least internal differentiation of rental and staging product line, where for which I'm working for and I'm the industry director for. We made a differentiation of the 4 segments. So first one is corporate events, second is public events, third is concert and festival, and the fourth one is broadcast. And related to that, we do have different products, but I will give you a short overview after we have spoken about each specific segment. So for the corporate events, what is important? In our opinion, I hope it fits to also your idea. is that the product quality and performance is quite high for that kind of application. And you can see I jump shortly to the last point, which fit for this every time. For sure, all still for a reasonable price. But we can see that especially the corporate events drive somehow the technology, which bring me to the second point, and is therefore an early adapter of nowadays more and more getting established technologies like 4K HDR. And it's also at the same time the driver for setting small pixel pitch products into the market to get high resolution. Just give you an example that for press conferences, as you can see a picture of a car show, for press conferences, companies like or customers like to use a small pixel pitch, smaller screen to have all those informations on. Later on, they will get dismantled after the press conference, and then for the show, let's say then they go for an ordinary or for a bigger pixel pitch, which isn't the small one anymore. So it's kind of go for high resolution on a smaller screen. Next is that uniformity means one batch ideally is needed, and as you may remember, the question of batch will be answered later. So all in all, it's kind of evaluation, pixel pitch against somehow resolution against screen size. So again, to give you an example of an application, it could be a small screen, HD. Let's go as small as possible. So, for example, pixel pitch 1.5, which would be 3 meter by 1.8 meter. So it's a 138-inch screen. And we can show HD on this size already. If we go next step to a pixel pitch of 2.5, the screen would be already 5 meter by 2.8 meter. So that is what is the result of changing the pixel pitch, keeping the resolution, and changing the screen size. So and there you could vary also the resolution, and then you need to find the best product fitting for this resolution, for the size of, let's say, hole which is available from the booth builder, and so on. And that is corporate events about. And last but not least, you can't see on my list, we also see conferences and shareholder meetings which belong to corporate events, which ask for redundancy and backup. And this is done by the control system, which could be Novastar, which could also be Brompton, as they now also have the redundancy. Next point are the public events. So what is important, or what are the important features or considerations for that? It's the viewing distance and the viewing angle, as you can see on the example, that there is a big audience spread out in the stadium, and they have huge different angles to the LED screen seen. So as wide viewing angle as possible would be nice for that application. And you can see also an LED floor, and there, you need to consider about the viewing distance. So therefore, this floor could be a bigger pixel pitch, as small pixel pitch LED floors are still quite complicated to produce. So it means the pixel pitch should fit for the purpose. It could be used, as you see on the picture, for visual effect or for ambience, but could also be used for other applications in the public events for information sharing, and that result in definitely different pixel pitches. And then for outdoor events, it need also to be waterproof, windproof, as well. It needs to have higher brightness. So at the same time, for public events, And it also comes to our next point of festivals and concerts. We need, as an LED manufacturer, to ensure that we have a big product portfolio. So, as I said, that brings me to the concert and festivals. And what would mean a big portfolio? I've spoken already about 1.5 millimeter, 2.5 for the corporate events. I've spoken about LED floor. I've spoken about outdoor LED screens. And here, as you see at the last point, sorry to jump there, it could be also mesh products to get a 3D stage effect. But what is important in addition for concerts and festivals, it's all about, you could summarize time, and it's also about weight. So you see that the setup and breakout time should be as short as possible, at the same time for huge screens, bigger sometimes than for the corporate events. At the same time, they need to be lightweight, as they are in the backdrop of a stage of a tent setup or similar. So means lightweight need to be achieved. The transport need to be as easy as possible, not only for the loading for the truck, means to have it on dollies, is also to have it in the right way, moving onto the stage, getting installed. And that means also friendly for the labors, so for the installation by itself. And the touring frames are needed to have the climbable function, which is the second last point on this list. And now we come to the challenge which we have as a manufacturer. At the same time that we have need to be fast setup, lightweight, it need to be strong enough, and that is really a challenge. And sometimes there need to be compromises, or you need really to specific concentrate on such application. Okay, let me move on. So we have at the last point of applications the broadcast, which have it really specific requests. So for sure they also go for the small pixel pitch. Why? Because the cameras quite often do have a very short distance, which is same than the viewing distance for a person. And for the TV, we need to avoid moire effect, as well as we need to reduce as much as possible any flicker. And that is, again, sorry to jump, the third point, that high refresh rate is important for that, but that's not the full story to reduce the flicker. There are also driver ICs, the number of pixels driven by one driver IC. So there are a lot of components for which we as a manufacturer need to take care of. And for you, the result is important, how to, or that it fit for broadcast as well. And there we come also to the last point in my list, that at the same time we need to have a very good grayscale, for example, at low brightness conditions. So a low brightness performance need to be quite good in TV studios, as the LEDs are mainly not driven higher than half of the brightness they could, because cameras would not be able to catch and to reproduce it, not being blown in the TV camera. And the second point, sorry that I somehow missed that, but I don't want to forget about. It's also quite important point. So nowadays, more and more we have HD cameras in the TV studio. That means a high resolution camera filming the setup. And that means the screen need to be very accurate installed. And it will get more worse for the situation once we come up with 4K cameras. So that is the point of view for features within the applications. And here you see a list of products from our portfolio, which we see do fit in all those 4 verticals. So you see that for the concerts, we add the Venus series. I've already spoken about that in the last webinar. And we also add the Mars series, which is the LED floor, which we see is suitable for public events, for concerts, but also for broadcast once we get the target of the 2.5 millimeter, for which we are still working on for the Mars series, for the LED floor, because that is not as easy as other pixel pitches. And and then the other product ranges, I think they are well known for you, starting with the small pixel pitch mini LED Aries series, going over to the most versatile series, which is the Polaris, and the Altair series used for concerts at the moment, and Jupiter and Lyra for the mesh products. Okay, let me come to the next question. So what are the main features and or advantages of LED technology? Please don't get boring. I will try to keep it as short as possible, and I will come up very soon with a conclusion why I like to mention it again. So I think people of you which are familiar with LED already know about the advantages, but let me shortly mention them again. So within LED, we have the best of both. What means both? It's the best out of video walls and the best out of laser projection. So first of all, with LED, in comparison to video wall, which we can see on the left side, we don't have seams anymore. And to make a comparison to the projection, we have high light output, but at the same time, we do have really deep black, because a projection screen has a white background for the reflection of the light, and as LED is a self-emitting technology, there is no reflection needed. Yes, there within the small LED, but that's a very small point of reflection and not a big screen. We have an advantage that we can use black instead of white. So here you see the summary. We have very high brightness as self-emitting technology. We have the deep black, and this is a good example for the left explosion drawing, which you can see, which is our IMD, our mini LED, and it's our Absen version, as this one has really a deeper black than others in comparison. So we really pay attention on the black level, as this make the pictures more brilliant. And the third point to make picture more brilliant are the vivid colors. I've already spoken about seamless, and what else need to be mentioned? It's the uniformity over time. So to make an example on LCD over time, you would see huge differences between the several panels. They can be also adjusted, but you don't see similar fast change of uniformity within LED technology. So these are the points which are important, and for sure, everything is about content later on, and that is my personal conclusion. So some people, as I said, may get boring for the advantages of LED technologies, and in comparison to LCD, and in comparison to projection. But I still see, having a look into the market and all the applications, the customers still not use the advantages as they could do. And that is everything about content. So if you use the vivid colors, if you use very high contrast pictures, you can work with the advantage of LED technology, and then everyone would be happy, as same as I would be happy as a manufacturer to see LED products used in the right way. Okay, let me come to the question how to calculate the minimum and the maximum viewing distance. So there is definitely all over in the internet a rule existing, a rule of thumb, which mention that, for example, 1.5 millimeter pixel pitch, you can see here in the middle. So the 1.5 millimeter pixel pitch, which results in a 1.5 meter viewing distance. So you can use this rule of thumb, definitely, but that's not the full story of the viewing distance. So what are the targets for the minimum and maximum viewing distance? So there we come maybe to the only disadvantage of LED technology, which is the pixel structure. You can see within this picture that when we have very close viewing distance to an LED screen, we can still see the dot by dot, the pixel by pixel structure. And that is not what picture should reproduce, as original picture don't have this kind of structure. So here you see an LED panel, just as an example. It's switch off. And if you switch on, you will see still the pattern of different LEDs, even that it is white. So what is our target for the minimum viewing distance? As I said, we want to get rid of the pixel structure, means such kind of shown white uniform surface. And that gets defined as the minimum viewing distance. Later on, I will show you a formula. So let me shortly come in between to the maximum viewing distance. You see here an example of our ISE installation beginning this year with a 1.5 millimeter Aries series. We also should consider for that kind of applications for the maximum viewing distance. And what is the target in there? This picture should show you, or should give you the imagination what need to be kind of transmitted to the audience. You see one vertical line of LEDs is on, and the next one is off, and the next one is on again, and then continuously in that pattern. So it means on, off vertically. And this is the information we want to show to the audience, ideally. Means if we have still the right viewing distance to the LED screen, we can still identify this structure of on, off. But once we get to a too far away position, means that we extend the maximum viewing distance, then we come to the same effect than we had before. We see a uniform white surface. But this isn't our intention. Please remember that I said the information or the content we want to show is an on-off vertical line. And this isn't reproduced by this screen anymore. So this is the point of maximum viewing distance that we can still see. And it's also to give the hint for the application. If you have a very small or very small letters on the screen, you would like to still read them, to read the information. But you can't if you don't take care about the maximum viewing distance. As you should get an idea of this picture, that on the left side, you can't see the information shown. And there we come to the formula. I don't want to spend too much time at this moment to explain the formula. You can have a look later on, as Alex said, that we are going to provide the presentation as well as the recorded webinar. So what is it about? It's about the ability of eyes on the left side. You see on the left side that there is 1 minute, means 1 divided by 60 degree, which can be covered by human eye. So there's really biology border or limitation, let's say. So, and that results in a formula, and you can have a look at the 1.5 millimeter. Remember the rule of thumb. which mentioned for the minimum viewing distance 1.5 meter. If we consider about the viewing distance able to catch by human eye, you see that it's more realistic that it's 2.6 meter. And the maximum viewing distance, remember what I explained before, the vertical lines on, off, which we want to still see, is the 5.2 meter. And here I already summarize other examples out of our available pixel pitches. But to come to the next slide, is it really interesting to have this range or to follow this range? I think those which have experience within the market, they know that no one really follow that strict those rules. So there is still a range to play with. Why I give you the example of the iPhones, as you see over the time of iPhone generations, let me point out shortly, hold on. So over the time, you can see that the resolution increased a lot at still a similar size of screen. What does it mean? So we have already reached the point that eyes are not able to see the pixel structure anymore, and the information of details is getting more and more on the same area of the screen. And but this is a trend which is followed for the iPhones, and is also a trend which gets followed by customers. So it's not only about viewing distance, it's also about a very nice picture, so a nice feeling. So the more pixels, the higher the resolution, the nicer the feeling. I think you can also imagine by yourself at home the TV. Does it really make sense to have a 4K screen on the wall? Is there really the need for an 8 screen for the next generation? So I think due to viewing distance, definitely not. But it looks nicer. So that is the answer for the viewing distance. So now I come to the viewing angle. And you see here an application where we have a very wide screen done by LED, and we have the point of view from the very right position onto the screen. So what is the target for, or what should be the target for a nice or good enough viewing angle? First of all, we would like to still enjoy a nice picture. We want to see still the native or the right colors. And it should have not only picture, it should also have the right brightness. That is the target for a viewing angle. So you see here a schematic drawing that to make an example how manufacturers do specify their viewing angle. And that, by the way, is the only specification. It's about brightness. So from straight view, just for an example, you have 1000 nit, and out of the 80-degree viewing angle to the left and to the right, it's until this moment bigger or equal than half of the brightness, means 500 nit. If we would go to 81 degree viewing angle, it might be lower than 500, and that is the value that get added in the spec sheets. It's all only about the brightness. And remember what I said before. What is our target for the viewing angle is to keep also a nice picture and for sure with the right colors. And none of the existing spec sheets out in the markets, really none of them, can give you an idea if the colors are still right. So it means, ideally you need to make a shootout, you need to have a look at by yourself, or you need to trust the manufacturer if there is still an acceptable and high quality picture even out of a viewing angle. So shortly to make also an example on the vertical viewing angle, because that is also influenced by another reason. So you see that even that you're very close to the screen, it's a 70-degree viewing angle, which is catching for or which fit for a lot of products, even for outdoor. And the more far away you go, for example, with the guy with standing at 10 meter, it's for him enough to have a viewing angle of 20 degree. And yeah, you see here on the example, as I said later on, you can have a deeper look and get a better idea. What is the reason for the viewing angle? Mainly, it's not the LED, it's mainly the louver. So means the kind of sunshade above each LED. So for outdoor products, especially, or for hybrid products, which fit for indoor and outdoor, you need to have a certain length of the louver. And that is the work the manufacturer needs to do. So what is the best balance length to keep a good viewing angle, and at the same time to get a high contrast or higher contrast due to this louver. And this is all about the pro and con and the consideration we as a manufacturer, or you, once you have the option of different shader lengths or louver lengths, you need to decide what is more important and to find the right balance. So here you see the difference or the advantage of a higher mask louver, that you have a higher contrast in sunlight condition. Let me now come to the second last question out of the ones I prepared. It's the difference between batch and calibration. So on the left side, you see a screen which do have a different batch at the top and at the bottom. You see it's not only that there is different brightness, it's really a different batch. And I just borrowed the picture from Linsen, which is another controller manufacturer. And what you need to know about the batch is that a manufacturer try to sell one batch per order, or normally can catch that one batch per order is delivered. But there is a limitation within the market, and it's within the market and not by manufacturer. So it's about 30 million LEDs. It's also a rule of thumb, which can be produced within one batch. So what is one batch? It's defined by blue, green, and red peak, means the wavelengths. So you can see here now a batch, let's call it number 1, and this could be batch number 2. So where you can see different peaks. And I hope this already gives you also the answer, because that had been the question in the past. So is there any improvement of working with different batches? So I don't know what we could improve, because that is a physical fact. So that a different batch do have different wavelengths, and at least at a certain viewing angle, you would be able to identify. Means, but at the same time, you can by software like Novastar and software from Brompton. The difference is more. The difference is the user interface, how easy it is to adjust them. You can make them as close as possible from the straight view, but the viewing angle would be still a topic. But maybe is acceptable for concert or other applications. So that's about the batches. You see here that it's defined by different voltage, by different wavelengths, and within a certain range of tolerance. So, and what is a calibration in comparison? you see that different brightness, different colors are spread out all over the screen and all over the cabinets and modules. So it means each individual LED is different, because I said a batch has its own tolerance. And here you see the summary again. On the left side, you select a certain batch. So this is defined by those ovals. And on the right side, what is done by calibration is to come to the lowest common denominator for each color. Means the green point would be here, the blue here, and the red there, as there is a huge variation of different green due to the millions of numbers of pixels. That's about calibration. Okay, let me come to the ground support quickly. Here you see a result of AX 1.5 being set up. These are the components. So we do have normally a foot for one cabinet in the width and for two. Then we do have the outrigger, and on the bottom right you see both both connected to each other. The other components is the ladder. We have a long one for two cabinets in the height, and we have a short one for one cabinet. And bottom middle, you see the stacking clamp, the attachment from between the cabinet and the ladder. Please don't complain on the picture in the middle. You see that the ladder is extending above the LED screen. This is just a schematic idea. For sure, we have a solution where the ladder isn't extending above the LED screen in the front. So here you see the range of adjustment of the adjustable feet underneath the foot. It's about 30 millimeter, and that you need to keep in mind and need to consider once you're going to set up a screen on a floor. So I suggest to start in the middle, as you see by step number 1. You see here, this adjustable foot should be in the middle position of its available range. This is really the middle of the lowest point in comparison to the highest floor point. And then work from the lowest point up to the highest point, and then you will see whether the adjustable range is enough or not. Otherwise, you need to add some material underneath, or you need to start from the beginning again. And that is the reason why I just said use selected feet. As a second step, tighten them up from the middle to the outside. And the third step would be level the back. What do I mean by level the back? It's to level the outrigger foots. As in the Z-axis, the screen need also to be leveled. It's not only for the horizontal or for this vertical. It also need to be in the Z-axis, where we later on are going to add the counterweight. And then the fourth is to double check. Maybe you need to do it 2 or 3 times, the double check, to come to a very good level. Why 2 or 3 times? It also depends on the pixel pitch. I here in the bottom right corner made a example of 1 millimeter offset. What does it mean for 1.5 millimeter pixel pitch? It's already more than 50%. Means if I have 2 millimeter offset, and the boost builder would mention to you, oh, that's not a lot, so 2 millimeter is fine, isn't it? Well, if you are going to set up a 1.5 millimeter LED screen, it's already more than 1 LED offset. So it means the LED or the line within the content is not in line anymore. It already has a jump to the next level. It has an offset. And so then let me quickly come to the counterweight. In the middle, you see one suggested counterweight. What is it to consider about? You need to have a certain weight. to give you an idea, a 5-meter screen behind this structure, you need 125 kilogram, just to give a small idea. And this needs to be handled by the number of different counterweights. So they are stackable, they can be carried. So therefore, I think these are the ideal solutions, even that we don't offer such kind of counterweight for sure. And here you have an overview that we try to do our best to keep the parts being used for the stacking as universal as possible to fit for different product series. But for sure, for the foot itself, as the cabinets do have different dimension, we can't cover that to keep them universal. And now, again, let us come to your questions, which I try to answer. So let me have a look at some of your questions. Hold on. Give me some time. So let me pick this one, COB versus SMD, which is better? I already answered that in the last webinar. So I give you a quick answer. So in my opinion, SMD is better. Why is it better? Because it still has higher black level. It has also still there is still the chance to repair SMD, where COB can't really be repaired. I need to correct myself. You can repair, because that is what all manufacturers are going to promote, or actually do promote. But if you ever have seen the result after a repair, maybe you would not be satisfied anymore, because you would be able to see the place of repair. Okay, let me pick another question. So there is a question, what's the best way to combat moire effect? So I was also thinking about to show you, because I already got this question also in advance. I made the preparation for what is moire effect, and just let me summarize by my words and quickly give you an answer. So the moire effect is a physical effect, means you have the squares of an LED screen which interfere with the squares of the TV camera, and this is where moire effect do come from, where those strange lines do come from. And the only chance for the moment is to go lower and lower with the pixel pitch to get aware of that. Another option is actually what I've also seen in the market, but what isn't available for us, is to come back to bigger lenses above the LED, so to spread out the light. But keep in mind that by this you can improve the moire effect even more than by small pixel pitch, but you will lose a lot of contrast. You will lose black level. And so there is not really a solution existing. So it's just kind of balancing to work with the moire effect. And by the way, if anybody tell you he has a software solution to avoid moire effect, don't trust, because it's physical. Okay, what else we do have here? So there is another question: is there a way to combine two different batches with similar pixels if you don't have enough screens? So as I said in between, there is still a way to combine different batches within one screen. It's not the ideal solution, but yeah, for example, as I'm quite open to all different manufacturers for processing, have a look at Brompton. They include a very nice user interface where you can select the cabinets with different batches and adjust one cabinet and then copy the correction data to all the other cabinets, and that can improve the visible effect. But I would just would try to keep you in mind for what application. For concerts, I see it can be done, and the quality level is already of this adjustment is already high, but not high enough for corporate events, in my opinion. So it really depends also on application, but can be done. Okay. What else? Are the adjustable crossbars for between the letters a crucial integral part of the structure for a ground stacked system? Let me think about. The additional crossbars. So it's it's all an option, and the I think the crossbars you mean. So we have two different. I don't have the picture at the moment. So we have the bars where you place the counterweights, as well as we have bars to improve the stability of structure once you go, for example, outside. I hope I cover your question in the right way. Okay, what else is there? Also see that we're a little bit running out of time. So let me go to this one as a last question. What about the bending effect on low brightness settings? How do you cope with that? So maybe I again explain what he means, because I have a very clear idea what he means. It's a kind of that you have looks like compressed video, especially in the low light areas of the content. And therewith I can just give you the hint, if you ever considered to change the brightness at another point than brightness within Novastar software. There is also a point of advanced color settings where, depend on the driver IC, you can sometimes adjust the current gain. And that means, reduce the brightness first of all by the voltage, and then you keep the full range of picture quality. That would be my way to deal with, but really depends on the driver IC being used. So I can't give you the full answer, as I don't know which product you speak about and which driver IC is in. Okay, so that would be, I think, the last question, as we already are out of time. And maybe Alex can take over to speak about what we're going to do next.
The presentation.
Yep.
Perfect. So we've had some really great questions, and thank you for answering those, Christian. So for any unanswered questions, we'll be going through those all, and we'll make sure to get back to you directly in case we missed that. So in terms of the next webinar, we've actually got one on Thursday. Apologies, it says Tuesday here, Thursday the 23rd. So for anyone that wants to sort of delve a little bit deeper into the technical aspects of the technology, we've got a two-part webinar, which is hosted by our technical engineer, Emre, who's based in our European headquarters in Germany. So please feel free to drop me an email, alexcousins@abseneurope.com, if you'd like to sign up. All the details to sign up will also be on our website. And if you go to the next slide. Great. So yeah, we think it's a good thing to do. We appreciate that you're probably inundated with webinar requests. So it's we'd like to make the most of the time. So please do share with us any feedback, comments. After the webinar is finished, you'll see a feedback box. So please use that opportunity to let us know your thoughts, good or bad, and we'll make sure to address those going forward. And on that note, just like to say thank you very much for joining. And any questions, comments, feedbacks, just please drop us a line, and Christian's contact details are there. So I will follow up with a follow-up email, which will include a link to the recording of today, as well as the presentation and details for our next webinar. So thanks again, and we wish you a very good week.
Yeah, also thank you from my side, and I hope I could somehow